Hi everyone, this is Dan Tzmon. I'm the host for today. I'll be just making some administrative announcement as we will start in just a few minutes. We're just giving some more time for people to join. I'd like to welcome you all to our fourth Photonics Experts webinar session. This one is also about the ASAM Open Scenario 2.0 that was just announced in December. This particular session will focus on requirements and Open Scenario 2.0. I think it's a good time to say that if any of you missed any of our former webinars, they are all available from our website on our Open Scenario 2.0 resource page. And you can get access from that page to recordings of former webinars as well as some of our technical blogs. Many of them, by the way, written by Sharon, who will be presenting this webinar today. Speaking of Sharon, I'd like to present Sharon, our webinar presenter for today. Sharon is our Photonics's solution architect and chief methodologist. He's a world expert in verification and validation, and he had led several of the work groups in this particular Open Scenario 2.0 standardization project. He also, as I said, written many of our blogs, and I welcome you guys to check those pieces on our blog and website. Just another technical issue. Questions and answers there'll be a session at the end of the webinar, and you guys are welcome to use. There's a specific Q&A channel on your Zoom that you can actually post your questions, and we'll make sure that Sharon will get them and answer them at the end. And that's about it. So thank you very much, and please take it from here, Sharon.
Thank you so much, Dan, and thanks everybody for joining. And we're just going to start with our session. So let me share my screen. And here we go. So automatic automotive requirements-based testing the right way. Here we go. So I only have one slide for recap from our previous webinars. And so you can go and check those out. Open Scenario 2.0 for those who missed that, and I doubt, but that's the new upcoming standard. It's about to be released in May. It's a language and then domain model for scenario-based testing. It's declarative, it's short, it's readable both for machines but also for humans. Enable all aspects of validations and verification. So it's both the scenarios, the KPI, the coverage, the checks. Everything is within single language. There's a lot of value in that, and we're going to cover that. It allows dual interpretation. So it's an input format. You can do whatever you want with it, and you can actually drive scenario, make them take place on CL, on other platforms, or you can basically monitor did this scenario occur or not. Standard, cross-industry standard, support all abstraction levels, and modularity, reuse. All of that is part of Open Scenario 2.0 by ASAM. I'm not going to go into more details. And this is, Dan already said that we organize the information for you, and just you can go there and pick up a lot of the information that we're accumulating. There's something going on, something funky going on in my machine, but hopefully those jumps will stop at some point. Requirements are key to our validation and verification effort. Like in all good presentation, the slides move on their own. I don't know what's going on here. Let me try. Let me try to get control over the ghosting that is going on here. Okay, so yeah, so before we start, let me go over the motivation, what could be added, because the automotive industry did adopt a strict and well-defined process for requirements. So here are just some of the opportunities of growth, of getting better in collecting and connecting requirements to the DMV effort. So complexity grows. So we need more scenarios per requirements, and just concrete scenarios or not without automation, that wouldn't be enough at this point. We're also climbing the automation in the automation level. So now there's more responses coming from the ego, more autonomous vehicle, and whatever you want, whatever you added as input to the test may not happen. And so you really want to know that the test intent was really met in those scenarios. And you have those scenarios, but there's a lot of risk dimension that needs to be added on top. So how do we combine risk dimension and requirements and span all those spaces and all those combinations? Scenarios may achieve, if I'm running any arbitrary scenario, it may achieve or fulfill two requirements or even more. So how do I take credit for that? This is about optimization. We're running a lot of tests, a lot of scenarios. If some scenarios actually met two requirements, can I get credit for that? And as a requirement engineers, well, which scenarios were executed for specific requirements? The VNV guys are going to take the use case of the requirements and kind of break that down to different scenarios to challenge the requirements. But how can the requirement engineer know what scenarios were tested, what was executed? And what if I overlook a requirement? This is a question that we get quite a lot. And there could be unknown or unpredictable need. How do I know that the set of requirements actually touches everything that could take place? Is there any solution for that? What checks were written for a specific requirement and how many failed? So requirements typically will come with some checks. Here's the behavior that needs to be maintained. There could be other checks that are added by the VNV guys. And if I'm looking at a specific requirement, I want to know not just how many failures overall were issued, but what is specific for this requirement? Is it, you know, if I'm doing AEB, I may not care about crossing the marking line. So it might be very interesting to someone else, but I want to be focused on what I'm doing as the owner of some automation function. So can I get that kind of information? Can I create an optimized regression for a specific requirement? So if I'm, again, the AEB, can I just tailor a regression which will be focused on the AEB or focus on a specific use case just for that? And I want to see the result and I want to see the amount of failures. Can I do that kind of a thing automatically? And improving cross-communication team, cross-team communication, sorry. So many times there's silos and lack of communication between individual. It's sometimes the English is the problem. So just communicating in English could be open to interpretation. And how can we bridge with that? So these are the kind of challenges that we have, and these are the kind of challenges that Open Scenario 2.0 help to address, and that's going to be the topic for today. We're going to discuss a top-level flow for how to achieve all these goals, leveraging the automation and measurability of Open Scenario 2.0. Just to give a further orientation, there's few practices or flows that are being used out there, and like requirements-based testing, that's going to be the main thing to be discussed today. But there's also scenario-based testing, and there's risk dimensions which we want to pile on top. And there's abstract and reusable scenarios with coverage, with measurability. And then there's the planning itself, the planning, how do we do the VNV planning, which is dependent on the requirements, but it's also, there's much more on the VNV that we need to do. Some of that coming from the requirements, some of that is not. This is the VNV team uses their gut feeling to actually try and explore some more. There is modeling the loop, and we're going to touch that and how that could be helpful and how that could allow starting the VNV process sooner than later. There is a safety case and residual risk that eventually want to produce. And what we're going to do today is we're basically going to connect the dots. So the relationship between them, and we're going to connect the dots and create one flow that marry all of these together. And for the safety case and residual risk, stay tuned. That is not part of this topic. There's so much we can cover in one session. So here's our agenda for today. And we're going to touch the aspect of a shift to the left. How we can shift to the left? Shift to the left means starting things sooner on the verification and validation. And then we're going to discuss the flow itself of the requirements. How do we do? What do we recommend? And what in OpenScenario 2.0 can help us become more efficient and more productive in our requirements flow. There is the mapping of the requirements to the VNV goals, to the multiple VFV goals, and eventually to observe data and to raw data that is being collected, coverage, KPI, scenario data that's being collected, and want to connect them to both the VNV goals and the requirements. That will be in that section. We're going to talk about KPIs, defining and tracking KPIs, requirements. Many times we'll have KPIs, they will have other things, but they will have behaviors and checkers and thresholds that needs to be verified, and we're going to talk about that, and then to our summary. Like Dan was saying, if you have any question, write those down. You can write them for yourself, or you can write them on the Q&A channel, and we're going to address those at the end. Let's start with the VNV shift to the left. So this is a trend by now in the industry, and we visit a lot of them. We work with multiple users, and everybody are talking about that, how to achieve that. So the traditional approach was to do things serially, like the requirements are designed, and we're going to implement, verify, and validate. And shift to the left just means we are going to plan and begin the VAV earlier in the development process. And there's multiple aspects to it. First of all, do more VNV earlier, leveraging virtual platforms. So software in the loop or model in the loop, these are things that you can do before. You can leverage this platform before and work on that. How soon should you start? Well, start at the beginning or even sooner, and I'll explain that. So before even a single line of stack code is written, you can actually create reusable scenario. You have discussions over the ODDs, so you can basically start accumulating those reusable scenarios that OpenScenario 2.0 enables. Before the tool chain was decided upon. So we work with a lot of users, they still haven't even selected their tool chain, but they know already things about their ODD, and they can start work on that. And before a specific project was launched, this is developing reusable assets, which we're going to touch and spend a lot of time on. Now, this is when I'm saying start sooner, it's not just for the high-level workflow, it's really scenario and use case level implementation. You can go into details. And this is how it looks like when you do the shift to the left. So you start the verification and you start the validation early on. You have much more time to do the verification and validation. You can spend more time and go deeper into details, into corner cases and edge cases that you sometimes don't have time to reach if you start later on. And yeah, I kind of mentioned that the tool chain. People are underestimating how long it's going to take even to select or try a specific technology. It always takes more time than expected, and you should definitely start working and creating your assets before you even adopt the tool chain. So just the value of shift to the left, the benefits, and reduce cost. So a known fact, the earlier you can identify a bug and remove it, that is the cheaper way to go. That there's going to be less implications and less effort, and overall in many aspects, that's a cheaper way to go. there's better efficiency, we're going to have team collaboration, with better goal if we're going to start sooner and have discussions going on sooner. There's going to be reductions of human error if you're going to do the shift to the left. You're going to set up the processes, they're going to work for you. The developers can always have something, some test week that they can try and explore and find those bugs sooner. So higher quality, I'm going to talk about that, always related to coverage-driven verification and open scenario 2.0 as well. But we're going to have some progress indication if we're going to have the test already created in scenario, already created throughout, and we know what have we tried, what is succeeded and what is failed. And like I said, because we're going to have more time to do verification and validation, and then we will spend more time on key tasks and key areas, and eventually shrink schedule. So parallel work, and you can even shift resources if you find out that, yeah, I'm doing okay in these scenarios, but I need to shift resources to both create or execute or debug other scenarios and other use cases. So you can do that with shift to the left. So that is our, I guess, our first tip for today is to start early, use shift to the left. I know it's a trend out there and many are already convinced and already finding different ways to achieve that. Open Scenario 2.0 enable a lot of that, and we're going to talk about it in the next chapters. So this is about the shift to the left, and let's move to the top level requirements flow. So here's the V model, and our industry is using the V model. Typically, we're starting from requirements you see on the left-hand side and breaking down the requirements, functional requirements, system requirements, architectural requirements. These are happening on the left-hand side, and there is the right-hand side, which is for the V&V and for the testing, and that kind of breaking is being done here as well. Now, on the left-hand side, we typically, it's not always the case, but typically it is going to be a requirement management system on the left. So it could be just an example, doors, JAMA, Magico, these could be your system requirements too. Now we do need to manage the verification, and there's much more effort and there's tons of data going on the verification, and for that we recommend using verification management tool. And what we're going to do is we're going to capture and decompose the V&V objectives with a verification manager tool, and we're going to talk about the gaps and how they fully traceable between them. And you're going to see the flow. And this V model was created to maintain better communication between both the level of abstraction and the counterpart design or development and the validation and verification side. But you'll see how we're even enhancing that further with this flow. So, kind of things that we're seeing out there is that working with multiple customers, people are using the V model, but they give different interpretation, different structure for the requirements, etc. So we're not intervening with that. Everybody can use their favorite terminology or structure, etc. And what we're going to be discussing today is just the right-hand side, and it is a generic methodology that can match any kind of structuring or any kind of flow that you are using in your company today. So we're mainly going to talk about the right-hand side, and don't worry, we'll talk about the mapping and how easy it is to map our structure to any kind of structure that the requirements guys are using on the left-hand side. The first thing I guess that we need to touch is the move from concrete scenario to open scenario 2.0 coverage. So traditionally, the V&V team will come up with a set of requirements, and then for each and every requirements, you're going to write a set of concrete scenarios or tests. So here are the tests that are needed to declare these requirements to be done. The challenges, as we already stated, that effort is growing and many concrete scenarios are needed. And that number is going exponentially. And we all know the digital transformation and all that stuff. It's unclear if the concrete scenario meets the original intent. I may want to do something and it didn't happen the way I thought it would be. And now I'm thinking I'm verifying, I'm thinking I'm validating the requirements, but I'm not. And there is the unknowns which we mentioned before. So open scenario, abstract scenarios, these are the things that we recommend using. And what you want to do is associate the requirements to coverage, which is part of open scenario. So to coverage, to scenarios, to KPIs, to checks, all these data-driven information. So the value of doing that, coverage is observed. So this is data-driven metric that is immune to the ego response to any kind of consideration that we took or didn't take into account. And we're just going to connect things to the coverage and see exactly what was observed. Random is applied. If you remember, with Open Scenario 2.0, I can always ask for specific things. I can ask for specific ranges. And whatever I didn't ask is going to be automatically randomized consistently to the things I did ask. And all the location dependencies will be taken into account, etc. So you're going to get a lot of surprising scenarios that are going to challenge the requirements and challenges your own thoughts of where the risk is. There is the automated scenario creation. As we know, with that level of abstraction, a tool can take an abstract scenario and create many, many scenarios following the same intent. So that is the automatic creation to work with scale, requirements, and checking recognition from any executed run. And so if I create a set of scenarios, it could be that one scenario actually fulfill the requirement of two things. And if you are using coverage and coverage is always there and KPIs are always being measured, it could be automatically mapped. The same scenario coverage and KPIs can automatically be mapped to multiple requirements if they're valid for that. So you get the recognition for any execution run for those requirements. So this is the first thing. The connection from requirements is actually to coverage, to that objective metric that is being observed. And here's a high-level flow, and then we're going to go into more details, but let's start here. So we start with a requirement management system. That's what we're seeing here. And the beginning, we might have row or possibly a subset of the requirements. And what we want to do is create a corresponding V and V plan to manage our verification and validation tasks. So in this one, we're going to expand all the requirements into multiple scenarios, KPIs, and checks that are needed for the specific requirement or use case. The second step, and you see that this process is not linear here. We're going to use an extendable library or abstract scenarios to efficiently and automatically explore the requirement space. And in this case, we're starting with the high-level model, which we find very useful. But there is a reusable set of scenarios that you can leverage and run. And they could be directly correlates to the requirement or could be added things on top. There's more risk dimensions, which are not mentioned as part of the requirements, but that will be here. And then we run with the high-level model. It's optional, it's not a must, but this will be very useful. We run and then we explore and refine the requirements. And we're also building for the specific ODD that we're using in this product, we're building a test suite and we may be enhancing the scenarios that are needed for this specific ODD. So this is the execution step, and then we're back to our verification validation management tool. We're going to observe the data. Observe the data, identify wrong behaviors, incorrect requirements, and other things. So you can look at the result. If there is a failure, the failure could be one of the three things. It could be, oh, there's problem with the test bench itself, and the assertion is poorly written. I need to fix that. The nice thing, the failures, you fix them once, and then they're fixed, and you can use them over and over again. It could be that we need to fix the bug with our eagle, with our DOT, and then it will be fixed. But it could be that we need to refine the requirements. So this is maybe a requirement was overlooked, maybe the threshold is not as expected or as specified, and that will go here. So that's that is the third step. And we have a note here, and it's important to remember. The V&V process is not just about requirements. You need to challenge a DOT in multiple ways. So there could be things which are further detailed in the requirements, but it could be other things which are sibling to the requirements, even top level risk dimensions that we want to cover. And like I hope that all of you or some of you have seen how things work with Open Scenario 2.0. You can always adjust each and every one of these. The scenarios, layer constraint on top, steer the randomization, tune thresholds if the KPI or the errors are issued at the wrong time, or refine the requirements. Now, with this kind of approach, you can connect concrete scenarios or other platforms. It depends if you're running on SIL or not, but it is possible to take all requirements for all platforms and get a full big picture of where you are in the V&V process. And yeah, this is the tune part. Now, we will say that, and we have a demo today, so we're going to see that today, but there is full traceability and information exchange between the V&V tool and the requirement management system. So the things are clickable, they're automatically getting updated. So you always have the fresh information in front of you. And if requirement engineer would like to see what are the scenarios that were executed for this specific requirement, you just click a button and you will see what's there. And you can see what failures are coming and why they're failing by clicking and getting into the verification tool. Now, when you move from the high-level model into the stack, now you have your requirements refined, and you have your test suites tuned and your scenario tuned for the specific ODD. You can even change the coverage goal to match your specific findings, and very quickly get up and running with the real stack. So that's the entire flow in a high level. As you see, and we will go over that in more details, this is an automated data-driven approach. There's not a lot of human interference, not place to errors. As soon as the execution of a test suite is done, information is being collected, the coverage is being aggregated and calculated to give you an intuitive view of where you are, what goals were met and what goals were not met. Map that to the requirement, you will see the result, the grade for each requirement, not just in terms of done or not done, but you'll get more information on each and every requirement. Let's go into more details of the various individuals and how they're going to use the tool and in what order. So here are the requirements. Engineers or the system owners, they're going to start with the requirements and breaking down the requirements and KPIs that I needed and place that in their favorite requirement management system. The next step should be a discussion of everybody involved. So the requirements guys, the developers, the test engineers, They all discussing the requirements. This is an educational process. They all need to be aware about the goals, each one of them bringing their own perspective into the requirements. Now, at this point, the test engineers will be familiar with a library of scenarios and KPIs, and this is this reusable generic library of scenarios is a source of information and expertise that was collected over time and over again, being leveraged and tuned to be accurate and reflecting real challenges, real thresholds, etc. So that is a source of information to be used as part of the discussion, even that early. Later, the developers are going to develop the stack, and the test engineers will do the decomposition. Look at every requirement. Okay, for each requirement, what kind of scenarios will challenge that requirement? Do all the scenarios are mentioned part of the requirements use case? They might be there or might not be there. What kind of KPIs will be interesting for any kind of analysis? So let me write those down. And these are very scenario specific, and we're going to talk about that. It's not just, oh, give me the mean TTC of the entire scenario. I want to know the mean TTC when I'm doing cut-in and slow at the beginning or at the end of the slow. That information is useful because there is context behind it. And Open Scenario allows creating that kind of data and collecting that kind of data. So you're going to also mix the scenarios that either are fully specified or you added on your own with multiple risk dimensions that, again, following your gut feeling, your knowledge, your experience, and try to challenge the requirement in multiple ways. So then there's the second point of reuse, right? We're going to take the reusable scenarios and run them and execute those. So the word about the planning is going to be a tedious process. Just discuss every requirement and what is valid for the ODD and what is not valid and what kind of information needs to be collected. But this is key for success. And this is something you want to start, because once you have it, you can use that, right, as a progress indicator. You can tell what is right and what is not right. So this is the requirements discussion. Now, I want to say that sometimes you will put just a stick in the ground and say, okay, these are the coverage, these are the ranges, these are the values I care about, etc. And once you start the simulation, you will tune that because you'll see how things behave. You will see where the risk is. So it's okay to tune the requirements and tune the coverage once we actually see the execution and simulation going. And once we're done with the execution, we're going to run things. Sorry. So we're going to take the test suite that we designed, and it's going to be milestone, and we're going to design test suites to be executed and take the stack and go through execution. It could be in multiple platforms. Now, as well as creating test suite on your own, and test suite could come as part of your verification package and validation package, you can actually create tailored optimized regression. I'm going to show an example of that, but I can just take the AEB, click on a button, and ask the verification management tool to produce a test suite which is optimized for AEB without any repetitions, without any redundant tests that don't contribute and not relevant for the AEB. So this is something that when you take that methodology and that process, a tool can provide for you. Next is the analysis phase. We're going to analyze, debug suspected issues. That's going to happen by the test engineer, and that's going to happen by the developer. If the issue turns out to be a bug, he's going to fix that. Otherwise, it might go into requirement engineer that will observe that and say, yes, that's actually a missing requirement or refinement that is needed, and I'm going to update things on the requirement management system. So this is the analysis part, and we have the coverage, which is a representation of both the requirements and my VNV goals. So I'm going to look at that aggregated coverage. It's all very nicely folded into very readable grades, and I can go into details if I want. And the idea is to check, am I done or not? If I'm not done, very easy to see the randomization to areas of holes, to coverage holes that needs to be fulfilled. So that is the coverage review itself. And this is going to happen in iteration. It's going to be happen in iteration until I fulfill all my coverage and I don't have issues. And it could happen in multiple iterations because I may have milestones, right? So I'm going to do this once for some basic pieces of the ODD or basic functionalities, take that process. Then I'm going to move to phase number 2, where I'm taking more of the ODD, more of the risk dimensions, and trying those out as well. So that's very natural as part of the requirements flow. And once I'm done with the entire ODD and the requirements are okay and the check seems I don't find any failures, I can just, from the information that was gathered, I can export reports. It could be KPIs, it could be coverage, directly from the verification management tool, or the information is flowing anyway to the requirements tool, so I can export reports out of that. So this is this kind of completes the entire flow. So I hope this is clear. I hope it makes sense. And if not, we will see that in the questions channel. So this is the high level flow that we propose. And I hope you can see that OpenScenario 2.0, both with the level of abstraction, with the measurability, with the coverage, with the ability to do checking, all of that is a big necessity. Even the ability to define reusable scenarios. So if my scenarios were locked into a specific location or some ODD circumstances that were selected in my previous project, I wouldn't be able to use it in this project. So everything is fundamentally hard-coded to use abstract scenarios. And let's talk about mapping requirements to VNV goals and to the observed data. So again, this is our V model, and this is what we're looking at. And we're going to, out of the requirements, create the executable VNV plan. I'll explain in a minute why I call it executable VNV plan. So the thing will be, inside the requirement, there's going to be different level of information, many times checking information. There could be some scenarios here. You need to do it like in a specific location or specific maneuver that needs to be verified. There could be some KPI, there could be multiple conditions that will translate into coverage, but there is a little bit of information there that we can build on as we build our verification plan. And so this is what we have inside the requirement. And for each one of them, we will make them complete. As the VNV team, that is our role. Well, what other scenarios could be there? What KPIs needs to be collected for analysis? What checkers are needed? So we're going to do that, running a little bit quickly because we said it before. And the V plan is really an executable V plan. So I can, if I won't just run all of it, if I won't just run scenarios that are valid for specific segment, subsections of the V plan. So I can actually create test suites and execution based on that plan and considering that plan. So from that plan, I can launch and manage massive test regression. Tests are automatically created and executed, tuned to the requirements needs. And we'll talk about inside my verification plan, I need to be able to differentiate between what requirements and what risk dimensions are coming from the requirements and what kind of things their V&V team risk or attributes. So this is what we're going to do now. Ideally, the V&V plan should be mirroring the requirement structure. We already said it's a superset, but if we can maintain the fact that it's actually going to do the mirroring, that's going to simplify the tracing and analysis of both. It doesn't have to be like that. It could be that the V&V is structured differently than the requirements, but it is possible to change the mapping between them. And not all the V&V plan is come from the requirements. We mentioned that many items are a combination of risk dimension. And this is the refinement exploration. We will find bugs, we'll find issues, we'll find limitations, we'll find scenarios where that we cannot, it's impossible to generate. And this is where the constraint solver or the Open Scenario 2.0 technology will be very helpful by telling them, look, I can never get into this kind of condition. It could be that, yeah, it doesn't matter. It could be that there is requirement or some limitation, ODD limitation that is not mentioned in the requirements and it should have been there. So this is all part of the requirements exploration and process that can take place. Now we kind of mentioned that the traceability between the tools, and it's very easy to kind of see what is mapped to what and report if there's some kind of limitation. Well, from which requirement it's coming from, what should I observe and check its relevancy. And so very easy to inform the stakeholder, giving guidelines. Here's the requirements, here's the issues I found, and he can even click by himself. We're going to do it in the demo. Click by himself and see what are the findings, what are the details of the finding that we just realized. So this is the mapping that we're kind of using here, right? Requirements are created on the left-hand side of the V model, and we're going to have a verification plan. Ideally, it's not a mask, mirroring the structure of the requirements. And then there is the raw coverage, KPI, and errors that are produced by the tool after execution. So all of these are mapped. And a single coverage coming from a scenario could be mapped to one or multiple requirements. Remember that, right? So the mapping is created, and this is how we get full traceability of plan to verification plan to the real observed data, the coverage data. So that's how the mapping works. This is just an example, and it's kind of verbose. There's no need to read all the details, but here are system requirements, and what you see that we created in our executable, machine-readable plan, we created a structure which follow exactly the structure of the requirements. Again, not a mask, but it will allow connecting and mapping and tracing between these two structures. And this is a combining requirements and V&V related concerns. It's easy to see within that segment for specific requirements what are the grades, what are the KPIs, what are the, everything is within a single structure, making it very comfortable to look on requirements and analyze. Now, this is just a comment that we recommend doing. So, like, you want to think in a structured way to make sure that you didn't leave any risk dimension behind. So many times when people refer to Pegasus, they think about the Pegasus 6 layers. They think about, oh, this is the top down, right? We need to think about it top down. But it's very useful to do it even for specific requirements. So not as a top-down structure, but for a specific requirement. Think about in that specific requirements, what are the scenarios? And from that, are the kind of road topologies that will be very interesting, and then furnitures, and then temporary changes, dynamic, and then the actors that could be, you know, static or dynamic actors. So you can think about that and leverage that a way of thinking for specific requirement. Not necessarily could be on top, or could be orthogonal to your decision about what would be on the top level. Would it be requirements, or would it be the Pegasus layers that will serve the top? But this is just one thing that we found very useful for get a complete cover of the requirements. Now, we're going to talk about the level of reuse. Verification plan can be reused as well. I'm going to talk about that later on. This is just, again, connecting what we're talking about today to what we've seen on previous webinars. So this is just a slide from the previous webinar. If you remember, this is our coverage definition. If you haven't seen that, I apologize. But for every scenario, you can define within the scenario a coverage goal, set the coverage goal. So cover vehicle category means I care about all the vehicle categories. This is an enumerated type. So this, it could be like a truck, a sedan, a van, etc. But I'm just saying I care about all of them. And it is a goal. So if I don't sample the cut-ins by all these vehicle categories, the cut-in is not done from my perspective. It wasn't thorough enough verified. So very easy, just one single line to say cover vehicle category means I want to observe cut-ins by all the kinds of category that exist. Now, there is an extension portion in here because I may want in specific ODD, well, I do not care about cut-in by VRU vehicles or trucks. I know, not the most intuitive example, but maybe that's what I am. I don't care about VRU vehicles or trucks. And now, how can I do that and still maintain? I don't want to touch the original code, right? I want to add that requirements of that specific ODD and that specific project on top of the reusable code without changing the reusable code. So this is the way to achieve that. I can extend the cut-in. So this could be and will be two different files. This is part of a reusable file, part of a verification package. And this will be project specific or ODD specific. And this is how you can override a previously created coverage attribute. So cover, I'm now going to override the vehicle category. And I'm just saying, well, ignore the vehicle category being either in the RU vehicle or a truck. So I'm adding here and ignore. So this is the way for extending a reusable coverage definition, a reusable goals for my specific project, my specific ODD. So I just want to mention that again to connect us to how it's all solved in Open Scenario 2.0. So very easily and very precisely, you can capture the requirements and coverage goals. And this could be extended. So this allow you, Open Scenario 2.0, allow you to create reusable assets. I'm not going to go into too much details. We have a full webinar and a workshop just for extensions. Go ahead to those links that both Dan and I shared to observe if you want to get more information about that. This is another ability that is opening up because of Open Scenario 2.0. So, and it's an example of mapping into a machine readable plan that could take place. And yeah, obviously I'm showing for Telix technology, but this is good for any generic methodology. So what you can do in our technology is you can build your verification plan here, and you can put checkers and coverage and KPIs here, and you can read in all your Open Scenario 2.0 implementation, and you just drag what you need into each and every categories. So that is how you build in your verification plan. So if you think about it, I can create my D structure to be coming out of the requirement structure, and now I can map the specific coverage, KPIs, and checks into this structure. So now I'm basically connecting all the data, my requirements, application plan, and the implementation data. So all of these are coverage groups and coverage attributes in Open Scenario 2.0. I just read it into the technology and I'm just mapping that, well, what is valid for what requirements. And it could be that one of these will be valid for more than a single requirements, obviously. So that is how this is being done. Now, there is reuse that can be done not just in the level of scenarios. So we're doing it in our technology. You can actually have links to full segments. Let me explain how this is useful. Maybe I created a project in which one of the important use cases was a junction or unprotected left turn in a junction. So, and now I'm going to create a new project, and this project actually have the same use case that I was using in a previous project. It's very easy to create a reference from a vPlan to a different segment, totally different project, or maybe part of my reusable verification plan. I can create a link to that and automatically get inside all the coverage, KPIs, and checking and the scenarios that are associated with it. And so this is a very good way to do reuse, right? I'm taking already mature, discussed, implemented content, and I'm associating and building my ODD needs accordingly, leveraging all that good work that was done before. And of course, I can add and modify and do whatever I want for my specific ODD, for my specific project. So this is like a full segment reuse. Moving to the next thing, which is the test suite. Well, we need to plan the project test suite. So a project will have milestones, and that's part of the planning session. There's going to be decision what needs to be, what is implemented, what needs to be verified in that specific milestone. This is correspond to different development phases, maturity levels. There's different ways to come up with the milestones, and the development requirements guys will come up with that. Now, each milestone may have its own test suite that needs to be executed. It could be daily or weekly. And on top of that, like we said, there's tailored test suites based on coverage goals that you might want to achieve. So you might want to say, well, this use case of a junction, I want to try just that because maybe that's a modification that I did. Or I want to try things in fog because just create a test suite with all the scenarios that fog is being involved. You can do that in a click on a button. And these are the kind of thing that if you follow this kind of methodology with a proper technology, obviously you can do very easily. I'm going to demonstrate that in the demo as well. So create a test suite automatically from the machine readable executable verification plan. Test suite processes should be fully automated, goes without saying. We're not going to click the button for the daily or the week. These are going to be automatically invoked for us, prevent a place for human error or forgot or anything like that. You can do it upon request if user needs to and decides to execute things, but this will be automated in your Jenkins technology. Here's just an example of test suite, and in specific, we want to touch the area of doing basic verification scenario and then opening up into more validation to more of the ODD, more risk direction kind of risk dimension kind of scenarios. So I kind of demonstrated that in the previous webinar. This is Fortelix way of capturing and controlling abstract scenarios. We're using spreadsheets, so you can always create a table for a specific scenario, and then you're going to say which map you want to run into and various categories that you want to control. So in this one, there is a cut inside, an ego direction, and car one direction attributes that you can control. There's tons of other attributes, but I just decided to control these. The rest are going to be assumed, taking constraint and the dependencies into account, right? And availability and location is going to be selected. So these attributes will impact what locations are going to be selected. Anyway, this is very good way, very effective way to capture test suite. But the point I want to make here, so on all these scenarios, I was very explicit in what I want, because this is just the basic verification step. I'm going to try very controlled scenarios, making sure that all the basic functionality is working as expected. Later on, I can either continue with some specific scenarios I want to get, but I can just avoid some attributes. Like if I don't specify the ego direction, it could be and would be randomly selected consistent with the rest of the things that I did select. So this is avoiding, and I can say fill. This is not just, oh, find one scenario, find all the combinations of attributes, all the attributes that would be legal in this scenario. And you can do fill of multiple attributes and get cross combinations of these attributes. So this one means try all the cat insights, which could be left or right. Start all the ego direction, left, right, or straight, and all the car one directions, which could be also left, right, or straight. So I can say fill in here, and what this fill does, it's going to go to the coverage, see what you've specified to be the goals, and follow your directives and complete the coverage goals that you just defined for the tool. But the point here is that this is a validation. This is more of a validation. We're opening up. We're producing tons of scenarios. You can see that it's not just one. I want to run these 5 times, and this one 50 times, and this one 100 times, right? Remember, there's always randomness. Random locations are going to be selected. Attributes which are not specified are going to be selected. Things are going to be adjusted. The speeds, the distances are going to be adjusted to selected segments. A lot of things are going on for you, replacing the manual work of creating scenarios. So yeah, and here's the tip, and I didn't say it explicitly so far. Notice that we're using exactly the same scenarios for both verification and validation. It's all about what constraint do we put on top to get a very concrete scenario, or to get a family or rich set of scenario spanning all the legal spaces that are assumed and inferred from your ranges and constraint, right? It's not just ranges, it's not just literal ranges like logical scenarios, it's abstract scenarios with dependencies and constraint. So with that, I'm going to move to a short demo. I'm going to use from requirement management system, I'm going to use Java and Magic Draw, use our own package and libraries. We're going to run 45 on a high-level model, and F Manager as our verification management tool, and we just going to experience the entire flow. Small educational example. Requirements and the functional requirements, and let me fold that. You'll see that we added here under the LKS, there is cut-in requirements and change lane requirements. This is something the requirements guys will do. Now, at any point in time, they could look at the result. You can see this is the LKS and the cutting and chain lane inside. You can see that none of them is done. It's still not done. And there's description here of what they are, but they're not done. Not only I can get the state of done or not done, I can get the VMV grade. So we're 44.97 with the change lane, and we're 49.11 on the cut-in requirement. So it's not just a number, I can get detail. I can also get, and I can see now that there's no failure associated with any of these requirements. So if I'm looking at failures or errors or issues, I don't want to see issues that are not related to what I'm trying to verify right now. And this is what I see here. There's none that are associated with the cutting and change lane. Now, if I want to go into further details and understand what, well, where's the 44.97 coming from? What kind of scenarios are associated with it? How many of them were run and what didn't run yet? So I can just click the button of the change lane and oh, I need to this and let me click just to show you that it's actually jumps to the change lane requirements. And this is where the 44.97 number is coming from. So this is the verification management tool that I've mentioned before. You can see, you can organize here not just the requirements, the one section that mirrors the requirements, but there's other VNV tasks that you can organize and manage from here. And you can see that there's 45.94, the grades for where we are right now. Much work needs to be done. We're not done yet. You can see the amount of runs. You can see how many have passed and how many have failed. So this is where we are. And but now I can go into more detail. So okay, so I know that I need to do much more for the change lane requirements, but what exactly? Let's unfold this. And you can see that if you just drill into that, there is a scenario which is called slow vehicle ahead with traffic. In this scenario, we're going to put one NPC in front of the Eagle, which is going to be slow. And to challenge its change lane capabilities, we're going to drive vehicles both on the left and on the right, blocking his ability to change the lane. And I can see that I'm doing pretty well with that. It's 93%, but there's much more. Well, there is a little bit more that I need to do if I want to get to 100%. So let's see how is that 93%. How did we get to that number, and what kind of things were tried and what kind of things were not tried? So just to would give you a sense of how coverage works. So you see, there's number of cars on the left, and we got 100% of it. I can click at that and show you how it looks. So the user here kind of wrote, I want to try on the left scenarios with 2 cars on the left, 3 and 4, and actually got a lot of these. So 55 times I got 2 on the left, 91 times 3, and for 54 times 4. So that is good. I'm happy with right hand side, and you can see the numbers. They're good as well. Now, with Open Scenario 2.0, you can actually express a cross. Well, have I tried this scenario with 2 on the left and 2 on the right, or 2 on the left and 3 on the right, and 2 and 4, and so on. So very easy, just one line to say, well, I want to cross these 2. And you can see that there is some crosses that I did very well. So yeah, I got a lot of these, 3 and 3 and 2 and 4 and 4 and 2, but I didn't get these combinations of 2 and 2 vehicles, 2 and 3, and so on. These, I haven't tried those at all. So either they're not important, that I should remove them from the plan, right? Or if they are important, I should fulfill those, and I should create scenarios to hit those goals that I want to verify. I'm going to show you a little bit of how we're fulfilling these goals very easily. I'm going to use the same test tables that we were looking at before. So here's the definition of a test table. And if you can see that it's slow vehicle ahead with traffic, but the only thing I want to specify here, the number of cars on the left. I want to fill that, and I want to fill the number of cars on the right. Fill that as well. So I want to get everything possible here together with everything possible here. Now, because there's 3 on the left that could happen and 3 on the right, this would give me 9 scenarios executed. So here we are. So I'm going to go here, and I want to show you. And this is how it works. Well, I wanted to show you the command first before running it. So here's the command. You just using the F-run, this is the technology that will activate and create a test suite for you, and just point to this table, this comma separated value, and you say, well, just create. I'm just using create. If I use dash dash batch, it will execute those, but I'm just using create. And when I'm running it, you'll see that 9 scenarios were actually executed. So created, 9 scenarios were executed. I can run those 9 runs if I want with dash dash batch, which is what is written here. Well, I'm not going to run this, so we will not have to wait till it's done, but I actually have the result right here. So here's the result right now. We're reading that into the tool right now. Did I open? Yeah, here we go. So now we'll go to the requirements, exactly the change lane, if you remember, and the slow vehicle with traffic. And you can see now that we're in 100%. We're 100% coverage. I'm going to, and here's the cross. Here's the cross, and you can see that we have 1 more for each and every bucket. I can, by the way, take the existing condition into account. We have optimization for that as well, but now I've just generated 1 more for each bucket. Now, if I want to execute right now, I want to create a test suite that will just run. There's a lot of repetition here, which I don't care about. We'll just run 1 scenario for each and every combination here. If that's what I wanted to do, that is very simple to generate that kind of test suite from your verification management tool, from F-Manager. So the way to do it is I'm just going to click the rank button right here. So I'm going to click the rank button, give me options. Do you want to get up to 100%? I can say 90% is enough. Or do you want to limit the number of tests you want to get? And yeah, 20 is enough. And I'm just going to click the rank. So we're basically ranking, and here we are. And like you can count those. There's 9 scenarios here that are selected, and they're without any redundancies, addressing those holes, removing the redundancies and giving you 100%. You can actually see what tests are selected with what seed, right? There is seed, there's random, there's seed. And you can see the cumulative grade, and you can see that as expected, each test is adding 11% all the way till we get to 100%, right? Because we have 9 of those. So this is how I produce a very efficient, no redundancies kind of scenarios. And that's how we got that. If I want to run that, I just click this button. It will create the F-run CSV file, which I can run. So yeah, that is about that. Now, since we run things, I can click the button right here to synchronize with the requirements management tool. So if you remember, when we look at the requirements, it's 44 point something on the change lane requirement. Now there's more. I can just synchronize by clicking the button here and refresh, and our 47.19. So this is the new result. Obviously, when running with a full simulation, in a project, this will automatically get updated. I wouldn't have to click the buttons. But you have full traceability from the requirement management system to your verification management tool, to your verification plan, and you can see all the details, what is missing, what is not. So this is about Magic Draw. We support, and there shouldn't be any reason why not to support all the other. Let me check and see where are I placed here. Here, this is JAMA. Yeah, I'm going to renew the session just to get that. So the same functionality, the same full traceability and transparency this is just a JAMA, and I can always click those VPlan sections and jump into, these things are, because this session is relatively long and they just lock themselves. There's a way to change that, but just lock themselves. So once I open that, it will just jump to a specific section and just give me what I care about. So this works with all requirement management systems or tools, and very easy to add a new one and connect it to your verification processes. So that's the end of this demo. If you have any question, again, either write them down or keep them in your head, and we're going to continue with a few more slides that I have, and then move to the VNV sections. So this was our demo. Let's talk a little bit about defining and tracking KPIs. So requirement, like we said, typically contain behaviors, and you can derive KPIs and checks out of that. This will be the source of the checks and KPIs. Usable VNV packages, they will contain ready-made checks. For example, there's going to be maintain a 2 seconds time headway distance to the lead vehicle in front. They're not related to any specific check. This kind of check needs to be tunable for specific project needs, right? Maybe if it's a truck, then I want to maintain more larger distance because of my ability to brake. There is checking refinements that will have to take place. Much needed, again, can be tuned from above with Open Scenario 2.0. So the same thing that we did, if you remember, the extension on coverage, I can do extension for checking and just tune and put the threshold wherever I need to put it, or dismiss a check for the full execution, for a specific phase of the execution. All of that is possible. These are critical things. Scenario can call one scenario while disabling its check temporarily, etc. Test can disable checks from the same reason. So this ability to define generic checkers, define checkers or KPI for a specific scenario, this is very important. I'm just going to give an example, like TTC, for example. I can just collect TTC as a generic attribute, which might be interesting, but it's very much open to interpretation. So 0.5 second TTC could be a great thing or a very bad thing. So if we just get to a 0.5 second TTC with no reason, I'm doing something wrong. But if there's some scenario, very dangerous scenario, in some kind of brave way, our ego was able to save the day and just came out without a collision and just 0.5 second TTC, that's a great thing. So the ability of connecting the TTC, the KPIs to the scenario, to a specific point in the scenario, that is very critical, and that is the kind of thing that Open Scenario can do. And this is just showing our with 45, there's tons of built-in checks that come along. It's just a subset of them, and very easy to extend the car policy, for example, and say, well, my mean TTC, my generic TTC, oh, the machine is going crazy as well, apologize for that. And my mean TTC to be 1.5 seconds. So very easy to make that change, and now all the scenarios will run with the generic thing. I can, if I want, just define my own scenario, or with a specific check, or with a specific KPI collected at a specific phase of the scenario. So this is just TTC at the end of change lane. You can sample at the change lane phase.end. Sorry for those who don't read Open Scenario, but and then on some kind of an event, if the change lane is smaller to some threshold, then we're going to produce a DOTR. So you can define both checkers and KPIs out of the requirements. It's not just generic. And actually, there's going to be more like this than the generic KPIs. Yeah, you can call external methods, etc., as you define your scenarios. These are very critical, obviously, right? As you go, you don't run 100 or 200 or 1,000 scenarios. You run tons of scenarios. You don't want to spend a lot of time analyzing. Yes, there's analysis that you cannot avoid and you'll have to do it. There's gray areas. But whenever there is a mathematical calculation or there is partial mathematical calculation, you want to put these assertions in place to always monitor, always do a little bit of the work, a little bit of the processing for you, and not just you doing it. So these are the checks that we have. And yeah, that's pretty much what we plan to show today. So we're ready for our summary. If you remember from the beginning, there is a shift to the left practice. These are very useful and very critical to project success. We recommend doing that. Start the VNV sooner, work with virtual platform, work with Mill. All of these will be very useful for you. Requirements are captured in an executable format. It's not the actual requirements, but it's all aspect like scenarios, coverage checks, and KPIs. All of these are executable. They're going to be collected. They're captured in a formal way, not open to interpretation. If you really need to code it, you really need to know what you're doing. Unlike in English, where you can say things and get away with some, round corners. There's going to be productivity on meeting the requirements goals. We've seen that every time. That people raise the bar on the quality. They can do more. If a lot of the things are happening automatically for you, you can spend more time on a specific corner case or focus on some risky area if that's what is needed. Automatic traceability is observed from all time, from requirement management system to the verification tool, all the way to the observed data, the data that was collected and observed within the execution. Exploring unknown, it's there, it's all the time working for you. It's going to surprise you in multiple ways. You're going to get some scenarios and say, oh, that is very interesting. That is something I didn't think of. And with our ability to control the system, you can even steer things for risk, steer things for unexpected, as opposed to repeat things, right? If you just go with the typical, you may just get the same thing over and over again. So very useful. You must do that. Try enough of and validate enough of the typical, but you want to get to the corner cases as well. And yeah, this definition break the silos across teams. There's better communication because it's with executable format, but it's connecting between the tool. You can jump back and forth, see what the VLV guys are up to, see how it translates to the requirements, and this just works great for everyone. And yeah, that's pretty much it. I'm done with everything I wanted to cover today. If any of this is interested, if you want to see how this is valid for your specific challenges, your own specific workflow that you're using in your own company, we can have a discussion over that. And yeah, that is the end of this seminar. We're waiting for some questions. And the next one is going to be about coverage coding guidelines. So we went a little bit backward. We touched the flow, what flow you need to do, the requirement flow, etc. But the next one, we're going to go, a little bit more into the technical, and we're going to look at the different guidelines of coding with Open Scenario 2.0 coverage. I mentioned that a lot during this session, but that's what we're going to do. So thanks everybody for joining, and let's take some time and look at the questions that were asked.
Thank you very much, Sharon. That was really interesting, and we have a few questions, and I invite all of you, if you still have any questions, please send them now. I think we have two questions. The first one was which simulators are supported with Fortify?
Yeah, so we have, I think by now, 15 simulators that being supported, both homegrown and commercial simulators. And as you guys know, our technology, this is a question about our technology and not Open Scenario 2.0, which I'm happy to answer, but just to put that. And so, yeah, and we became expert in connecting to multiple simulators. We become better and better in doing that. And I can see that Dan provided some of the answer, like Carla.
This is for you to read, Sharon. This is
okay. IPG, displays, Automotive. There's much more. We can provide that kind of. We'll be happy to provide that kind of information if you're interested.
But
so yeah,
Sharon, if I just may add, people ask specifically about Carla, which we support, Sumo, and we also support Virus, as well as Sharon was saying, DSpace, Automotive, and now recently, hot from the press, we just announced something like an hour ago that we are also supporting NVIDIA DriveSim. So, for us, being an open platform, supporting different tools is part of the DNA. Which connects me to the next question, Sharon, which is a question about simulator to AV stack data, streaming like LiDAR, radar, etc. Is it also supported by Fortelix, Fortify?
Well, yeah, let me answer that question. It is, and it depends what kind of control do you want to get, for these sensors. So we can do it at any level. Let me maybe take a step back. Open Scenario 2.0 is basically you can coordinate different actions to be executed. These actions could be just moving actors like pedestrians or vehicles on the street, or changing the light on the street light. Or it could be even injecting fault error or activating things internally inside the car, the driver. That is up to you to define. So basically, we can either control the behavior, the traffic, things outside or inside, or we can go to the next level of detail or control more internal things if that is needed. Most of the time, users will create different circumstances to challenge the leader, the radar, maybe to challenge the fusion. Oh, let me find a place where, the leader will have difficulties and the radar will do well, or that point in time, well, this is doing well and this is not, and see if I can challenge the fusion. So there's multiple things we can do. We can go into the object level and modify things, and we can corrupt images. Like there's a lot of things you can do. So the answer is yes, and it's just, I guess, what is there something specific that you have in mind? We'll be happy to explain how it's been achieved. If there's more questions, let me stop the sharing and see.
I think we are, I think we're good. Once again,
Okay.
thank you, Sharon, for a very interesting and informative session. I look forward to our next webinar, probably in June. We'll provide the exact date. Once again, about coverage, which is a really exciting topic. And thank you for being with us tonight, this morning, wherever you are. And we look forward to talking to you and being in touch with you soon. And please feel free to contact us with any questions. We probably will put together another blog with question and answers in the next few weeks. So if you have something which you'd like to ask, don't hesitate, just send it to us via the contact us. Thank you so much. Have a great rest of the day. Thank you.
Yeah, just there's another question. If this being recorded, would it be shared? The answer is yes. I kind of shared at the beginning that there is a Open Scenario 2.0 resources we're organizing for very simple reference, and you can choose, including a question that were collected in the previous blog, previous seminars. We collected that, so you can see that there. And this, if you go to our, I don't know, Dan, you probably can explain that better. So here's Natalie, just we'll send you an email to all participants with the recording. And thanks again for everybody for joining. Thanks for the time.
Thank you very much. Have a great rest of the day and have a great weekend. Thank you.
Bye-bye.